कंसेप्ट को समझने के लिए पूरा वीडियो जरूर देखें।
Chemistry Learn with Fun with your lovely friend, teacher, mentor, Shiksha ma'am.
Hello my dear students, how are you? I hope you all are doing great. Those who are watching my video first time, for them I have given link of my last video in the comment box. Have you learned chemistry with fun with your Shiksha ma'am? I hope so. As you know, we are learning here the atomic structure series. Now, in this session, we are going to learn about shell, subshell and the orbitals. So, let's begin. Those who have watched my first video, they can easily recognize what is this? Yes, you are right. This is an atomic structure. According to the Bohr's atomic theory, the electron in an atom arranged in shell, where shell is denoted by N. And what is N? N is called as principal quantum number. Okay, where N represents the number of orbits. Shell also represents by some alphabet, as I taught you in my last video, that is K, L, M, N and so on, where N is equal to 1, it means K shell, where N is equal to 2, it means L shell, where N is equal to 3, it means M shell. N is equal to 4, it means N shell. Now, got it? Click the screenshot. K shell. K shell is nearest to the nucleus and has least energy, and those shells which is far away from the nucleus has highest energy. Now, the next question is arised, how to electron distributed in different energy level in different shell? The answer is maximum number of electron in each shell calculated by 2n square, where n is the principal quantum number or number of shell. Now, we will see how many electrons can take place in different energy level. Let's see. First, K shell is equal to 2n square, where n is 1, first energy level. 2 into 1 square is equal to 2 electrons. Second, L shell, 2n square, where n is equal to 2. 2 into 2 square is equal to 8 electrons. It means 2 electrons enter only in K shell and 8 electrons can take place in L shell. Similarly, third shell, M shell, 2n square is equal to 2 into 3 square, it means 18 electrons. Fourth shell, N shell, 2n square is equal to 2 into 4 square is equal to 32 electrons. Now, you can understand very well how many electrons enters in different energy level. For example, lithium. Lithium has 3 atomic number, where according to the electronic configuration, 2 electrons take place in first energy level. It means K shell. In the K shell, 2 electrons can take place. Rest of the 1 electron can't enter in the first energy level. Why? Because only 2 electrons can take place in first energy level, and the rest of the 1 electrons will go on second energy level. Now clear? I hope you all can understand very well. Now, the next topic is subshell. A subshell is a subdivision of the main shell or orbit, and subshell is labeled by SPDF, where SPDF is a secondary quantum number. First shell, K shell, has 1s subshell. This is very easy to learn that how many subshell present in the main shell. Number of main shell is equal to number of subshell which is present in the main shell. Easy. For example, first shell, K shell, has only one S subshell. Similarly, second shell, L shell, has two subshell, that is 2s and 2p. Third shell, M shell, has three subshells, that is 3s, 3p, 3d. Similarly, fourth shell, N shell, has four subshells like 4s, 4p, 4d, 4s. Understood? Let's see a chart. By this chart, you can easily understand how many shells present in any atom, how many subshells present in the main shell, and how many electrons can hold by the subshell.
Make a note and click the screenshot of this chart.
Now the next topic is orbitals. Orbitals are area within atoms where there is a high probability of finding electrons. In atomic theory and quantum mechanics, an atomic orbital is a mathematical function describing the location and wave-like behavior of an electron in an atom. Let's see quickly the shape of orbitals, then in detail.
Orbitals.
This is very simple to know the shape of atomic orbital in organic chemistry. We have three axes in x, y and z plane. All three-dimensional axes present in perpendicular to each other. The nucleus of atom is at the center of three axes. Most first, nearest and smallest orbital around the nucleus is 1s orbital. Attraction with nucleus, probability of presence of electron is high in 1s orbital. 1s orbital is a sphere and 2s orbital is also a sphere. Remember, the s tells us the shape of the orbital, that is a sphere, and the 1 and 2 tells that how far the electron in different energy level. 2s electron have higher energy than the 1s electron, therefore 2s electron more distant from the nucleus. That's why 2s orbital larger than the 1s and 3s orbital larger than the 2s. The other orbital is in three-dimensional space is p orbital. There are three 2p orbitals along with the three axes, that is 2px, 2py and 2pz. The three 2p orbitals are oriented perpendicular to each other. The shape of p orbital oriented like lobes and it becomes dumbbell-like shape. Once 1s orbital is filled, then 2s orbital, afterwards the 2p orbital begin to fill.
For example, carbon has 6 electrons. Hund's rule asserts that if multiple orbitals of the same energy are available, electron will occupy different orbitals singly before any are occupied doubly.
Remember, we have the three 2p orbitals, that is 2px. Next would be the 2py and last would be the 2pz. We should be able to think of the electron on an orbital around the nucleus of carbon. How would be occupied? Carbon with the nucleus has 1s spherical orbital that has 2 electrons in it, like here. We also have 2 electrons in the 2s orbital which would be filled after the 1s orbital. Carbon also has 2p orbital. 1 electron occupied in 2px orbital, then 1 electron will go on 2py orbital. According to the Hund's rule, electron does not enter first in pair along with the axis. Last 2pz orbital, it will remain vacant. Now, whenever you will think about electronic configuration, you will think about this diagram. However, we should understand one more orbital principle, that is nodes. Two types of nodes present in an atomic orbital. Radial nodes, a thin surface between the 1s and 2s orbital where the electron density and probability of finding electron is 0. It means spherical radial nodes पर इलेक्ट्रॉन मिलने की संभावना 0 होती है. इलेक्ट्रॉन मिलने की संभावना 2s ऑर्बिटल और 1s ऑर्बिटल में होती है, जबकि रेडियल नोड पर 0 इलेक्ट्रॉन्स होते हैं. Second type of node is angular nodal plane, which is present in the p orbitals. When the electrons enters in any axis, the nodal plane creates in between rest of the two axes, जहाँ इलेक्ट्रॉन मिलने की संभावना 0 होती है. Small recap: spherical s orbital, 3 dumbbell shaped 2p orbitals, 5 3d orbitals along with the axis, and the last 7 4f orbitals. I hope you have understood very well this concept. In next video, we will learn about quantum mechanics and electronic configuration. Till then,
केमिस्ट्री लर्न विद फन से जुड़े रहने के लिए डोंट फॉरगेट लाइक शेयर एंड सब्सक्राइब एंड बेल आइकन को दबाना ना भूलें. कीप लर्निंग.